Lesson 4-1, the distributive property. Okay, let's start by taking a look at this simple problem. There are 4 children. Each child has 2 blue pens and 3 black pens. How many pens is that altogether? Well, we can write this problem in 2 different ways. One way would be to express the number of blue pens in total, which would be 2 times 4, because each child has 2 blue pens, and there are 4 children. And then express the total number of black pens, which would be 3 times 4, because each of the 4 children have 3 black pens. And because we want to figure out how many pens there are in total, we will add these two amounts. The number of blue pens in total is 2 times 4, which gives us 8, and the number of black pens would be 3 times 4, which gives us 12. 8 plus 12 gives us 20. So we know there are 20 pens in total. Now we can also set up this simple expression in another way. We could say that each child has 2 blue pens and 3 black pens. And to figure out the total number of pens, we would take this amount and multiply it by 4, because there are 4 children. Now we could use our traditional order of operations and evaluate what's inside our parentheses first, and you would be completely correct in doing so. In that case, we would say 2 plus 3 is 5, and 5 times 4 is 20. However, instead of using that method, we will use a property known as the distributive property. The distributive property states that whenever we're multiplying a sum or a difference by a number, we will take that number and distribute it, or multiply that number by each term inside the parentheses. So in this case, we're multiplying positive 4 by positive 2. 4 times 2 is 8. And by positive 3. 4 times positive 3 gives me positive 12. 8 plus 12 gives me 20. Please note that in both cases we arrived at the same answer. And that is simply because these two expressions are equal. We just wrote them in 2 slightly different ways. Okay. Let's try a couple more examples using the distributive property. Okay, in this case, I'm distributing my positive 4 to my positive 5 and to my negative 3. Please note that I am paying careful attention to the sign that comes in front of each number inside the parentheses. Once again, I'm multiplying 4 times positive 5, which gives me 20. Four times 5 is 20, and 4 times negative 3 gives me negative 12. 20 minus 12 leaves me with 8. Okay, let's try a few more. Negative 3 times negative 6 plus 2. Okay, in this case, I'm distributing my negative 3 on the outside to my negative 6 and to my positive 2. Negative 3 times negative 6 gives me positive 18. Negative 3 times positive 2 gives me negative 6. 18 minus 6 gives me 12. Let's try a couple examples using variables. Negative 2 times 9 plus x. Okay. Remember, in algebra we treat variables or letters the same way as numbers. We follow the same basic rules. So in this case, I'm distributing my negative 2 to my positive 9, and also to my positive x. Negative 2 times positive 9 gives me negative 18. Negative 2 times positive x gives me negative 2x. Now we are going to ask ourselves, are there any like terms that we can combine? Well, I only have two terms in this expression. I have a negative 18 and a negative 2x. Since they do not have any like terms, since these are not like terms because they don't have the same variable in common, then this would be our simplified expression. Negative 18 minus 2x is our final answer. Okay, let's try one more. Negative 5 times negative x plus 6. Okay. In this case, we are distributing negative 5 to negative x and to positive 6. Negative 5 times negative x gives me positive 5x. Negative 5 times positive 6 gives me negative 30. Once again, we will ask ourselves, are there any like terms? There are not, so 5x minus 30 is our simplified expression.